Good morning, boys and girls. Today we are doing lesson 12. We actually have two small lessons wrapped up in this one lesson. The first is a review of place value all the way through our trillions spots. And then we are going to discuss a little bit of how to do multiple step problems. The multiple step problems part of our lesson will involve some important vocabulary words for you to mark and memorize. In fact, in general, this lesson would be a terrific one for you to leave a little bookmark in or a page marker, post-it tab, because until you get these things memorized, you may want to be referring back to this lesson often. Let's begin with a review of our place value. In our number system, the value of a digit depends upon its position. The value of each position is called its place value. Let's quickly review our chart. We remember that the furthest digit to the right is the ones digit, followed by the tens and hundreds. I sometimes refer to these as our basic units. Typically then there's a comma, and then we have our thousands units. And in this we have our 1,000s, 10,000s, and 100,000s. A comma, and we move to our millions. And again, you'll hear the ones, tens, and hundreds repeat. A comma, and we're in our billions section. The 1 billions place value spot, 10 billions, and 100 billions place value spot. And finally, all that we're going to do today is to move into the trillions. We have our 1 trillions, 10 trillions, and 100 trillions section. Let's look at some examples. In the number, I'm not even going to try to read that. It says, what digit is in the 10 millions place? Well, let's look. These are our hundreds, thousands, millions. The 10 million spot is this middle one, 5, and hopefully we'll figure out that the digit 5 does sit in the 10 millions spot. In other words, that 5 isn't worth a plain old little 5. It actually has a value of 50 million. In the number 5,764,283, what is the place value of the digit 4? Now in this case, we're asked the place value. That's a different sort of question than asking the value of. We want to know the place value. In order to answer this, I do need you to write out a word. So, looking at this, the 4 sits in the thousands spot, and I actually do need you to write out the word thousands when you answer this sort of a question. And turning the page. Large numbers are much easier to read and write if we remember to group every set of 3 digits starting from the right and moving to the left with commas. Our brains are much better able to organize the information, and that's partly why we use them. So when we're given a string of digits like this, first begin by inserting your commas after every 3 digits. Now we have a number that looks like that, and we're able to recognize that this is our units, thousands, millions, billions. And now we can begin to read this number much more easily. 1,234,567,890. Commas help us read large numbers by marking the end of the trillions, billions, millions, and thousands sections. We need only to read the 3-digit number in front of each comma, and then say trillion or billion or million or thousand when we reach the comma. In example 3, we're asked to use words to write the number, and here it is. First, insert commas, just like has been done here. And then to write the number using words, we begin by reading 1 When we get to the comma, we know that's the 1 is in the millions section, so we write 1,000,000, comma, 24,000, comma, 305. Note that when we are writing the number using words and letters, we do insert commas in the same places we would if we were writing the number. In example 4, we're asked to use digits to write the number 1,250,000,000,000. If it helps you to sketch out a blank master, go right ahead, and then you can get your digits in the right spot. So 1 trillion means 1 will go here. 250 billion means we write 250 here. And there is nothing else, so we round out and finish this number by filling zeros in all of the remaining spots. And there we have it. Now, moving on to multi-step problems. The operations of arithmetic are addition, subtraction, multiplication, and division. Notice some very important terms we need to know so that we can often do our problems correctly. The sum is the answer when we add. The difference is the answer when we subtract. The product is the answer when we multiply. And the quotient is the answer when we divide. Once again, sum is for addition, difference is for subtraction, product is with multiplication, and quotient goes with division. Now, if we start to look at some sample problems, you'll understand why it's important to know and understand and memorize this vocabulary. In example 5, we read, what is the difference between the product of 6 and 4 and the sum of 6 and 4? Well, in this single word problem, you'll notice we see the word difference, product, and sum. We are actually going to do all 3 of those math operations, but we need to know what they are and do it in the proper order. So, let's begin by breaking the problem down. What is the difference between the product of 6 and 4 and the sum of 6 and 4? Well, before we can find the difference, we need to first find the product and then the sum. So the product of 6 and 4 will be the answer after we multiply, and that is 24. The sum of 6 and 4 is the answer after we add, and that is 10. Now we can find the difference between these two numbers. 24 minus 10 is 14, and our answer is 14. When you solve these problems in homework and on tests, I do want you to write out and show your work, please. And turning the page, it's now time for you to practice. A, B, C, and D involve big numbers, and E involves knowing all of those terms. Be sure to show your work with E. Notice that D asks you to use digits. In C, you're going to write out words. B asks you the place value. That will be a word answer. But A is simply a digit answer. Have fun with this.